really is made up of two parts. There's the unit circle part, you know, all those questions about the unit circle, and then the formulas. With your formulas, make sure you know what all your variables represent. So what is S?
S is the arc length.
Okay, it's a distance on the outside of the circle. So it'll always be something like inches, centimeters, feet, so forth. Just a linear measure. What is R?
Radius.
And it will have the same type of units. Okay, what is T?
Time.
Seconds, minutes, hours. What is theta?
Central angle or degrees, or sometimes pi stuff.
Right. It'll either be in radians or degrees, but in order to use it in the formula, we have to convert it into radians. So I might give you a degree measure to start with, but you always have to change it into radians before you can use our formula. Alright, what is capital A?
Area.
Okay, so it'll be something like square feet, square inches, square meters. V?
Linear velocity.
Okay, so it's a velocity, so your units will be a rate. So inches per second, feet per minute, miles per hour, so forth. So when you see those rates, it's either V or omega. Omega is angular velocity, and it will be radians per something, radians per some unit of time, so like radians per second, or radians per hour, or something like that. It could be in revolutions, but if it's in revolutions, you have to convert it first. Just like if your angle is in degrees, you have to convert. We always have to have radians if we're going to talk about theta or omega. All right, so those are all the variables we use. The formulas will be given to you. So let's look at number 1. We want the linear velocity, so that's V, of a wheel with a radius of 7 inches, which rotates 9 RPM. RPM, I should have spelled it out. That means revolutions per minute. RPM is something you see in the real world a lot. Mechanics, they talk about RPMs a lot. So it means revolutions per minute. So here is the problem. I told you that to use omega, it always has to be radians. So before we can actually use this, we need to convert. So can help if you set up as a fraction, 9 revolutions per minute. We need revolutions to go away, so since it's on the top, we put it on the bottom. 1 revolution is all the way around the circle, which is 2 pi radians. So we'll use that every time we're converting with revolutions. So then those cancel. So we get 18 pi radians per minute. So now I have R and omega. I'm looking for V. So V equals R omega. So you have 7 inches times 18 pi radians per minute. Radians are like that extra unit. If you have too many things, it goes away. If you don't have enough, that's when you throw in a radian. So 7 times 18 would be 126 pi inches per minute. If you multiplied out the pi, that's okay as well. I would take either. All right. Any questions on that? I know you guys didn't ask about it, but can I talk about number 2? We want the radian and degree measure for theta. So theta is the thing I'm trying to find. The radius is 1/10 centimeters. And theta cuts off an arc of length 1/2 centimeters. So we could do S equals R theta. So S is 1/2 centimeter equals 1/10 times theta. So you can divide by the 1/10 or multiply by 10, either way. The centimeters drop and you just get 5. Now when you put theta into a formula, it has to be radians. That means when you get it out, it's radians. Okay, it's not the pi that makes something radians. So this doesn't have a unit, that's 5 radians. I also asked for the degree measure. So if you have radians, how do you get degrees?
5 times 1 over pi.
Okay, if you need to, you can even write in. This is radians, so for it to cancel, the radians have to go on the bottom. So that gives us 900 over pi degrees. Or you could actually divide it and give me a decimal. It's like 286.5-ish. Okay. Number 3 was pretty straightforward. Number 4, what did you have to do before anything else? Right, change degrees to radians. Do we need to go through that one? Okay. Same thing on number 6, you have to convert first. So you guys didn't want me to work out any of those? Let's look at number 12. Okay, the diameter of a Ferris wheel is 185 feet. None of our formulas involve diameter. So we have to figure out, what is that number telling me? Diameter is total distance across the circle. What can you use that to get? The radius is half the distance across. So if the diameter is 185, the radius would be 185 over 2. Or you could give me that decimal. And that was in feet. 1 revolution. Okay, so I'm going to put theta. 1 revolution means all the way around the circle. I don't want theta to be in revolutions, so what would I have to call it? Yeah, a revolution is all the way around. How many radians is that?
2
pi. That takes 15 minutes, so my time is 15 minutes. Find the linear velocity. Okay, so my linear velocity, I can do v equals s over t, but I don't have s. Or I could do v equals r omega, but I don't have omega. So we just have to pick a formula, and then we're going to find something else first. Which formula do you want to use? R omega. Okay, so to get omega, we can do omega equals theta over t. So theta is 2 pi, t is 15. So my omega is 2 pi over 15 radians per minute. So then v equals r times omega. So if you multiply those, so 37 pi over 3. My v, I'm looking at units. This radius was feet. This was radians per minute. So the radians would disappear. So this is feet per minute. Okay, which is fine, except for I asked for miles per hour. So 37 pi feet over 3 minutes. I like to write it like this so it's easier to set up my conversion. So if I want my feet to disappear, they have to go on the bottom. I want miles. 1 mile is
5,280 feet.
and my minutes to go away, they're on the bottom, so I put it on the top. So we want hours. We know that there are 60 minutes in 1 hour. So if we multiply this out, 37 times 60, different ways that you could write your answer. You could say 37 pi over 264. I did say to the nearest hundredth, so if you go ahead and multiply the pi in and divide, you get 0.44 miles per hour. So on these conversions, if you write out what you have and you write your units with it, it helps a lot. And then try to set up that fraction so you can see, okay, I need these to cancel. So 1 on top, 1 on the bottom. Anything else on this page that gave you trouble? Did we get number 11 that you had to use 2 formulas with? And you know, like numbers 8, 9. It's tempting for people when they look at those thetas because they don't have pi's. A lot of times people treat those as degrees, but if they don't have a degree symbol, that is your radians, so you're just plugging them in. Let's look at 13. So a pulley has a radius of 12.96 centimeters. Suppose it takes 18 seconds, so that would be my time, for 72 centimeters of belt to go around the pulley. Okay, so your pulley is circular, and the belt is wrapping around the outside. So if I use 72 centimeters of the belt, what variable is that?
Yes.
You could also look at the units, centimeters, so it's linear, so it's either our S or our radius. We already had the radius, so it had to be the argument. So part A wants the linear speed, so we're looking for V. We could do V equals S over T. Yes, is 72 centimeters times 18 seconds. So if we reduce, that gives us 4 centimeters per second. B, we want angular speed, which is omega. So we could do omega equals theta over t, but I would have to find my theta, and we could. Or we could do V equals R omega, and we already have both of those, so I'll use that. So my V is 4 meters per second equals R times omega. So we divide by the 12.96. In fraction form, that's 25 over 81. Or if you actually divide it out, it's about 0.3086. And that would be radians per second. And I asked for radians per second, so that's our final answer. Is that one okay? I know you guys didn't really ask about 14 and 15, but I want to go through these all the same. So your test, the first page of your test is going to look like this, and I am going to say without a calculator, because these are the ones that we should be kind of familiar with. So what I'm going to do is have you do that page and there'll be all these questions that without a calculator, then you'll turn that page into me, and then you'll get your calculator in the rest of the test. So let's talk about how we could do these. Now, I am not going to require a unit circle as part of the test. On the last quiz, we all filled out a blank one. I have blank ones, so if it helped you, you may have one on the test, and you can fill it out, but I am not grading it, okay? So what I'm wanting on these is for you to hopefully be recognizing. When I see 45 degrees, I really shouldn't have to use my calculator to do the conversion because we've seen it enough times at this point. 45 degrees is the same as what? So that's what I'm hoping you recognize at this point. Now, why I don't want your calculator, we could do times pi over 180. And you could figure this out without a calculator. You're going to get your pi. 180 divided by 45 is 4. That's how we got here. But I'm wanting you to think about these a little bit more. So 270. Okay, so we think this is like my unit circle. This is my 0. 90 is pi over 2. 180 is pi. Okay, you're adding pi over 2 each time. So 0, 1 pi over 2.
3 pi over 2.
2 pi over 2 is where the pi comes from. This is 3 pi over 2. Now, could you get it by doing the conversion? Absolutely. You could divide both of those by 90. 270 divided by 90 is 3. 180 divided by 90 is 2. That's where the 3 pi over 2 comes from. But if you're familiar with your circle at all, these should be easy questions. So 240. Okay, maybe a little less obvious. So let's talk quadrant and reference angle for a second. What quadrant is 240 in? Reference angle. So 240 minus 180 is 60. Okay, we know that 60 degrees is pi over 3. And in the third quadrant, the pattern is the top is 1 more. 4 pi over 3. Do you guys see where I'm getting these without pulling out a calculator? Do you feel like you could do that? D, 330. What quadrant is 330 in? Reference angle. 360 minus 230 is 30. So we should know 30 degrees is pi over 6. Okay, in the fourth quadrant, what's the pattern? Double minus 1. Because it's like subtracting it from 2 pi. So 6 times 2 is 12, minus 1 is 11. So 11 pi over 6. Right. Worst case scenario, if you get that on the test and you blank, you can do this, but without a calculator, you're going to have to think through it a little more and try to reduce these things. Okay. Let's talk about 15. So going the other way. We should know at this point, pi over 6 is the same as 30 degrees. Okay, why? If you do your conversion, if you multiply by 180 over pi, pi's cancel, 180 divided by 6 is 30. B, pi, everyone should know this, pi is the same as 180 degrees. We use that conversion every time we go between degrees and radians. C, 3 pi over 4. Okay, what quadrant is 3 pi over 4 in? Reference angle, anytime I see a pi over 4, I know that's 45 degrees. So 45 degrees in quadrant 2. So 180 minus 45. 5 pi over 3. Okay, so we know in the first quadrant, it's always just pi over. Second quadrant, the top is 1 less. Third quadrant, the top's 1 more. Fourth is double minus 1. So that's quadrant 4. Reference angle. Anytime I see pi over 3, that's 60 degrees. So 60 degrees in quadrant 4, so 360 minus 60, 300. Okay, and of course, if you wanted a blank circle to fill out to help you, you could, but you would also, you can't use a calculator to fill out the blank circle and then say, okay, now I'll take the page without a calculator. You don't have to do that. Is this okay? So number 16, we did ask about these, so let's talk through. These are the exact same as the last page of test 2. The only difference is on test 2 they were in degrees, and now they're in radians, but it's the same thing. So when I see this is back to our hand trick. Pi over 3 is in quadrant 1. We know everything's positive in quadrant 1. Pi over 3 is like what degree measure? 60. So think about your hand trick for 60. So tangent square root of the top over square root of the bottom, so radical 3 over radical 1 is radical 3. B. Cosine of 2 pi over 3. Okay, so if you filled out a circle, you can look at that and use it to help you, but without a circle, we can think, what quadrant is 2 pi over 3 in? Reference angle is pi over 3, which we know is the same as 60. In quadrant 2, back to our all students take calculus. Sine is positive, so cosine would be, 60 degrees. So cosine square root of the bottom over 2, so square root of 1 over 2, so negative 1. C. Sine negative 5 pi over 6. So anytime we have a negative, if we're in degrees, we add 360. If we're in radians, we add 2 pi. Okay, that's like 2 over 1. So that would be like 12 over 6. So negative 5 plus 12 is 7 pi over 6. What quadrant is that in? 3. Because the top's one more. Reference angle is pi over 6, which we know is the same as 30 degrees. In quadrant 3, all students take tangent's positive, so sine is negative. Sine of 30 degrees. Square root of 1 over 2, so we get negative 1. Angle here. We know this is quadrant 3. Reference angle is the pi over 6 or 30 degrees. In quadrant 3 is tangent positive or negative? Positive. Tangent of 30 degrees, so square root of the top over square root of the bottom. And we get radical 3 over 3. Is everybody with me here? Pi over 6 is in which quadrant? 4. Reference angle is pi over 6. 30 degrees. Okay. Cosecant is the reciprocal of sine. So sine of 30 degrees is 1/2. So the reciprocal of 1/2 would be 2. In quadrant 4, all students take calculus. Cosine is positive, so sine and cosecant would be negative. Okay, so again, it's a negative, so we're just going to add 2 pi until we get a positive. Okay, so if you add 2, you get negative 11, negative 9, negative 7, negative 5, negative 3, negative 1, positive 1. So this is cotangent of pi. Okay, that's not really in a quadrant, so we can't necessarily do the quadrant and reference angle per se. If we think about our unit circle, that's right here. This is the point negative 1, 0. Cotangent is x over 0 is
Oh, alright.
Is that better? You guys think you could do that on your test?
I just have one question on C.
Uh-huh.
I did it a little bit differently, like
Okay.
I just did, like, kind of ignored like the negative and did the 5 pi over 6 was in quadrant 2 and reference angle 30 degrees and then brought down the negative at the end.
Okay. So that worked, but it kind of uses a property that we haven't talked about yet. So it worked because it was sine. If it had been a cosine and you did that, your sines would actually be off. So it has to do with even and odd functions, and the fact that sine is opposite signs in quadrant 2 and 3, but cosine is negative in both of those, so your sines would have been backwards. So you're right, but by chance.
Okay.
Other questions? Um, 17, I know we only asked about C, but can I talk through the rest of them? Because this is something that I think we've had a little more trouble with. If you choose to fill out a unit circle, that might help you on this. If you're looking between 0 and pi over 2, what quadrant are you looking in?
Quadrant 1.
And I'm asking you when cosine is square root of 2 over 2. Okay, if you're looking at a unit circle, is cosine the x or the y value? The x. So if you're looking at your circle, you're looking in the first quadrant, when is x radical 2 over 2. If we don't have a circle, we can think about our reference angle. So when is cosine radical 2 over 2? So we know like cosine of 0 is 1. Cosine of 30 is radical 3 over 2. Cosine of 45 is radical 2 over 2. So this is like 45 degrees, but since my interval was in radians, let's answer it in radians. So 45 degrees is the same as pi over and we know pi in quadrant 1, your reference angle and your angle are the same. So it's just pi over 4. B. We are between pi over 2 and pi. What quadrant is pi over 2 would we be in if we're going from pi over 2 to pi? And we want to know where in that quadrant is tangent equal to a negative radical 3. So let's think about reference angles. The negative we know is just because it's a quadrant, so I'm not really worried about that. So when is tangent radical 3? So tangent of 0 is 0. Tangent of 30 is radical 1 over radical 3. 45 radical 2 over radical 2. 60 radical 3 over radical 1. So that's it. So this is 60 degrees, which we know is the same as pi over. Okay, in quadrant 2, we know the top is 1 less, so that would be 2 pi over 3. C. If we are between pi and 3 pi over 2, what quadrant is that? So, I don't know, where is secant equal to 2 radical 3 over 2? Okay, we're not as familiar with secant and cosecant, but we know secant is the reciprocal of cosine. So if I flip this, get your radical off the bottom, and that's negative radical 3 over 2. So when is cosine negative radical 3 over 2? Reference angle. So cosine of 0 is 1. Cosine of 30 is radical 3 over 2. So we're talking about 30 degrees, which is pi over In quadrant 3, we know the top is 1 more.
Cosine.
Nesting between 0 and 2 pi. And this sine, -1/2. Okay, pi over, or 0 to 2 pi, that's the entire circle. But I need my sine to be negative. So in what quadrants is sine negative?
Quadrant 3 and quadrant 4.
So those will be where I get 2 answers from, each of those quadrants. Now if you fill out a circle, you're just looking on your circle, where is my y -1/2? If we don't have our circle, we think through it. Reference angle, when is sine 1/2?
When it's 45. No.
And 30 is the same as pi
Pi
over.
over 6.
In quadrant 3, the top is 1 more, so that would be 7 pi over 6. In quadrant 4, double minus 1.
11 pi over 6.
Any questions about those? So last one, problem 18. Okay, I told you this was a point on the unit circle. So the unit circle, we talked about the common points, but it's a circle. It has an infinite number of points on it. This is a different one. However, we know that on the unit circle, for any ordered pair, the x is, and the y is. So I asked for all fixed rate functions. So sine is negative radical 42 over 7. Let's do the reciprocal. Reciprocal of sine is cosecant. So if I flip that, get the radical off the bottom, we get negative radical 42 over 6. Cosine is the x. So reciprocal cosine is secant. Get your radical off the bottom. You get radical 7. Okay, tangent is sine over cosine, or y over x. How do you divide fractions?
Multiply by the reciprocal.
So these 7's drop. Since the 42 and the 7 are both under a square root, you can divide them. So that's negative radical 6. So cotangent is the reciprocal of that.